Cool. Hello, everybody. Hello. Welcome back. Can everyone hear me okay today? I know yesterday my microphone was being a bit dodgy, so if you guys are here and ready and can hear me, please drop me a little message in the chat, just so that I know that I'm not sounding like a robot again. Fantastic. So yeah, welcome back to another one of our workshops as part of the Gnosis Chain Hackathon. Cool. So today we're building with Hashi. Is that right?
That's the one.
That's the one. Awesome. And yeah, so hopefully this next kind of hour or so will give you guys the skills to get going on Hashi and get you guys building your projects enthusiastically. Auryn, are you ready to go?
I think so. Yeah, there we go. I'm good to go.
There we go. Awesome. Cool.
Yeah,
well,
right.
I will stop talking now. Take it away.
No worries. Cheers, Angela. So hey, everyone. I'm Auryn from Gnosis Guild, a team at Gnosis. We work on a whole bunch of different things, usually kind of DAO related, but one of our recent projects is Hashi. So we're going to be diving into that today, kind of explaining a little bit about the architecture and kind of design principles of it, and describing some of the things that we'd like to see people building, kind of focusing on, and then, yeah, I think if we have time, which we should, this is a relatively short kind of presentation, then we can kind of take questions of it kind of around Hashi, and I can dive into the code and we can just start kind of poking through it so folks can see where it's at. I will say, just as a quick disclaimer, this is still a really young project. So we've only been working on this for I don't know, a short couple of months. It's mostly unaudited. We do have a kind of preliminary audit report on it, but it's not something that's kind of production ready yet. You are getting to get your hands on it at a really early stage, which means you can be kind of really impactful in helping to shape what it looks like moving forward. We think this is a really important piece of kind of the cross-chain, cross-layer EVM ecosystem, essentially for kind of securing it. And so we're wanting to make sure that we get lots of external input onto it, onto kind of our designs and our implementation, lots of external kind of insight and kind of validation to make sure that this thing operates as expected and is secure. The entire premise of it is around essentially building more secure kind of bridge ecosystems. So I guess so. Yeah. With that context and kind of warning, this is totally unaudited. Don't put it in production. Let's dive in. So introducing Hashi. At its core, Hashi is a hash oracle aggregator. It allows builders to essentially create what we call a RIHO, a redundant array of hash oracles. So for those familiar with kind of building computers, this is a term that's kind of analogous to a RAID, a redundant array of independent drives. And the main goal here is to distribute trust among multiple distinct bridge implementations. So essentially, you don't have to trust any one bridge mechanism, and rather users can leverage layers of redundancy in their bridge-dependent systems. When I say hash oracle aggregator, we kind of try to be very generic here about what Hashi is actually kind of aggregating. Really, it kind of can be used to aggregate anything that can kind of conform to this mapping of integer to bytes 32. So the kind of canonical use case that we're thinking about is, I guess, twofold. One for bridging block headers. So that would be kind of integer. The first one would be domain, your chain ID. Second would be the block number. And then the bytes 32 is your block header, the hash of your block. And then the other canonical use case we're thinking about is for message bridging. So same thing, it would be chain ID to message ID to message hash. So yeah, this is why we're kind of using this relatively generic language in terms of hash oracle aggregator as opposed to something more specific. We want to make sure that it communicates well, that this thing can kind of be applied to anything that can kind of conform to that mapping. So why Hashi? In 2022, I guess we built Hashi because there's been this kind of alarming trend of loss in code by bridges or kind of bridge-related exploits. There was more than $2 billion worth of tokens or assets lost to bridge-related exploits in 2022 alone. 4 out of the top 5 exploits on Rect News on their leaderboard are bridge-related. I think 7 out of the top 10 or 8 out of the top 10. I think what this kind of our takeaway from this is essentially no bridge implementation is 100% secure. All bridge designs have some trade-offs in terms of cost, in terms of security, auditability, all that good stuff. And so, yeah, our takeaway is that we should not be building kind of security critical systems that are solely dependent on just one bridge implementation, but rather trying to build in some kind of redundancy. So our design principle here is we want to kind of standardize around the lowest level, essentially hashes and hash oracles, and then have diversification on the and the kind of modular infrastructure to allow for the mechanism to be totally agnostic to the underlying mechanisms by which your hashes are being kind of aggregated. So it's modular and agnostic to the underlying mechanisms used to construct this kind of RIHO setup, this redundant array of independent hash oracles. So for Hashi, we want standardization at the lowest level. We want this kind of modular agnostic design. We want to prioritize security over latency. It's much more important that the right hash gets across the bridge as opposed to just a hash getting across the bridge within some period of time. Obviously, there's practical limitations to that, but yeah, the important correctness is more important for speed for us. And then lastly, prioritize redundancy over cost. So Hashi is likely slower and more expensive than just about every other bridge mechanism because it's combining multiple bridge mechanisms. Because it requires consensus between multiple underlying mechanisms. However, that cost, we think, is well worth it for the additional security, for the additional redundancy. So kind of the main components here at the top here, I mean, the things that you would build on top of it would be things like token bridges, governance bridges, NFT bridges, anything that's kind of passing messages or reading state on one layer from another layer. And then the kind of components of Hashi, or the main components of Hashi is the Hashi core contract, which is this Oracle aggregation contract. It's essentially just you pass it a list of Oracle adapters and it queries each Oracle adapter for its hash, for the hash that it reports for a given domain and ID. As Giri-Giri-Bashi is a governable Oracle adapter, so it just adds a layer of kind of governance to your Oracle adapter, so you can define which Oracle adapters are canonical for which domain IDs, and have kind of a governance process, whatever governance process you define for making changes to that setup. The Oracle adapters are the thing that kind of interpret messages from each of the various oracles. They obviously all have very different mechanisms to kind of resolving what the canonical hash should be for a given ID, resolving what the block header is or what the message hash is or whatever. So we have this kind of generic adapter framework. You build an adapter that exposes a specific interface and then kind of how you get the adapter to actually figure out what the block hash is from a given oracle is kind of your challenge as someone implementing one of these adapters. And then for cross-chain messaging, we have this Yahoo, which is our message dispatcher contract, Yaru, which is this message executor contract. So Yahoo is where you kind of send a message on your origin chain. Yaru is where the corresponding message would get executed on the destination chain. And then we have this Zodiac module, which allows for kind of cross-chain governance, where a kind of designated address on the origin chain can be the owner or controller of an address on your destination chain. So you could allow things like, say, a DeFi protocol to have its governance on mainnet, but control deployments over on Arbitrum and Optimism and Gnosis Chain and Polygon and kind of wherever else. So a quick overview of the architecture. It's a little bit messy. And this is kind of by design to a certain extent, or as an artifact to a certain extent of this Raiho-like setup. So over on the left-hand side, we're kind of using this canonical example of a token bridge. Your token bridge contract would reach out to our message executor contract, Yahoo, and then that would trigger whatever processes are kind of necessary to push the message over the various different bridge mechanisms. So we'll have this kind of message executor adapters that, message relay adapters that push the messages out where it's necessary to push them. Then on the other side of the bridge, you have various bridge mechanisms that will kind of resolve the hash via whatever their independent messages mechanisms are. Attached to each of those, or kind of reading from each of those, is a Hashi adapter. When you want to actually kind of trigger execution on that destination chain, then your message executor is going to call your Giri-Bashi instance, which we'll call Hashi, and then query each of the Oracle adapters on that destination chain to confirm that they actually agree on what the canonical hash is for your given message. If they all agree, then your executor contract is going to call out to the other end of your token bridge and perform the corresponding kind of mint or burn action triggered by the token bridge on the origin side. So yeah, I guess what could you build? What would we like to see people building on top of Hashi? One thing that we're very interested in is additional Oracle adapters. Particularly interested in ZK bridges. Some examples of these are Succinct Labs, Telepathy, Dendra, ZK Collective. But really, I think it's important for us to have a wide variety of different mechanisms that we could leverage for any given route between two networks. It would be ideal to have kind of at least three, if not 5 or 7 different mechanisms and different kind of styles of mechanisms. So ZK Lite clients are great, but also kind of Oracle committee style bridges like the Gnosis Chain AMB bridge, or like Wormhole, and then kind of more optimistic bridges, or bridges leveraging different mechanisms. The more the merrier, essentially. If the more kind of choice that users have in terms of which mechanisms and what thresholds of mechanisms they want to put their bridge dependent systems under the control of, the better. So yeah, additional hash Oracle adapters is a really big one. Outside of that, contracts for validating storage or event proofs. So essentially, given a hash, contracts that allow you to then or I should say systems rather than contracts, systems that allow you to kind of extract or kind of prove that some storage exists at that given hash, or some event happened at that given hash, to then allow you to kind of validate that you should be able to do something on this destination chain. And so this is really useful for, again, things like token bridges, but also really useful for things like cross-chain governance. If you want to prove that a given vote had a specific outcome or something like that on your origin chain, then something like a storage proof and event proof is really handy, or is a really nice way to execute on that. We'd also love to see alternate versions of Giri Bashi. This is our governable hash oracle aggregator contract. So things like different aggregation and governance rules. Our first version of this was very basic, where you essentially just have an owner account, and that owner account can kind of arbitrarily change most of the storage variables whenever it wants. And we're currently working on implementing a version of this that has some stricter restrictions on what governance can actually do. So essentially, on the happy path, when all the bridges are behaving as expected, then governance has no power. And it's only once governance starts to misbehave that it's actually able to make any, not governance misbehaves, that it's when any of the oracles start to misbehave, then governance is kind of granted some powers to replace them. And so we think this is an interesting way to make a kind of setup with Hashi where you have kind of less governance attack surface. And then obviously the last thing here is just any end-to-end applications built on top of it. We'd love to see implementations of things like token, NFT, or governance bridges built on top of Hashi, either as proofs of concept or as fully fledged applications. So some resources for Hashi here. We do have a handful of the current versions of the contracts already deployed on various testnets. So if you want to dive in and just start playing with them on a testnet, then go right ahead. The repo is at github.com/gnosis/hashi. We have a handful of already implemented adapters for you to play with for the Gnosis chain, MB, the telepathy, Sync Labs telepathy light client, and Connext. But yeah, we'd love to see more of those implemented. If you want to find out more, you can go and check out the documentation and our kind of developer resources. I'll caveat that by saying Hashi does not have any documentation actually listed on the documentation website here. So all the documentation for Hashi, what little documentation there is back in the repo here. The code is definitely the documentation for the time being. And because we're pretty early, it's definitely still a little bit of a moving target. I think the kind of adapter interface and the Hashi interface is probably pretty stable at this point. But there's always the chance at this relatively early stage that stuff might get rugged. The interface might get rugged. Yeah, I see that there's a couple of comments in. Oh no, it's just Angela. Thank you for posting those. Great. So yeah, that's the end of the presentation here. I guess we can kind of take it one of two ways, maybe not mutually exclusive. I can either jump in and start showing some code and just kind of playing around with it some more, or if folks have questions, we can dive into answering some questions.
Yeah, I think we can open it up to the floor. If you want to drop a little message in the chat just to say what you guys prefer. Yeah, I personally would love to see a bit of code and see you kind of getting stuck in, and just kind of a little demo of how to get it up and running.
what I'll do is I'll get, we'll start sharing some code, and then if folks have questions, then we can dive in. Just, I will not have a view on chat. So if there is there's any questions, then just let me know, and I can come back over and check them out.
For sure, I'll jump in. I think everyone wants some code or a demo, so
show us the code. Show us the code. All right, great. So
Katya says the graphics is really cool as well.
Cheers. So this is playing in my working branch where I've been hacking away in this kind of quarantinable version of Hashi. Still needs a more fun name, but we'll dive in to start with just on the Hashi contract. This is the kind of base contract for this whole setup, and essentially it's got it does. That's just essentially. It's got three functions. It's get hash from Oracle, get hashes from oracles, and then get hash. And kind of one is going to essentially total down to call the next and call the next. So the interface that you're most likely going to interact with here, the function you're most likely to interact with here is get hash, which is basically just going to iterate through a list of Oracle adapters and check that they've reported that that each of the oracles is actually reported, and that the oracles all agree with one another. If any of the oracles in the array of Oracle adapters that you passed in disagree with one another, or if any of them did not report, then the call will revert. So it's a fairly kind of basic setup here. For each oracle that you pass in, it's going to call this get hash from Oracle function, which is just part of the iOracle adapter interface. So each Oracle adapter needs to implement this function, and kind of what it does is up to the adapter and obviously the underlying Oracle that it's interacting with. So if I jump into, I'll do the A and B Oracle just because that one's, or A and B adapter, because that one's kind of fairly straightforward. We can take a look here. So the A and B adapter is going to reach out to the arbitrary message bridge contract. And it's essentially going to only allow messages that I should say the arbitrary message bridge. We should step back a second here. On the origin side, the arbitrary message bridge is built for sending messages as opposed to sending block hashes. And so we have this header reporter contract that we wrote here to kind of coerce it into sending block headers, block hashes. This one, essentially, you pass it an array of block numbers, and it's going to try to get those block numbers just from, let's have a look. It's going to try to get those block numbers just from the, let's jump into here, into our header storage contract. It's going to try to get the block numbers from the global variable, just block dot hash. I'm trying to remember where that bit of code is in here. Regardless, it has this kind of limitation of only having access to the previous 256 blocks from whatever the current head is. This is kind of a limitation in solidity. And it's just going to put those into storage so that you can then go and pass them over the bridge. Once you've got your your block number, so it's going to call store block headers, build this array of block headers, and then pass that array of headers over the A and B with this required to pass message function. Then on the corresponding side on the destination chain, you will now MB adapter. The arbitrary message bridge will call this store hashes function for each ID and each hash. It's basically a kind of structured message that came from the header reporter contract over the bridge. And essentially, it's just going to check that the message was valid, came from the right A and B contract, the right chain ID, and from the header reporter contract on the other side. So a relatively simple way of coercing the A and B into reporting block headers for us. So coming back to Hashi here, essentially each Oracle adapter is going to kind of implement its own mechanism for doing something like this. In the case of this AMB reporter, it has this kind of weird way of, or the AMB adapter, sorry, it's got this weird way of kind of coercing a mechanism that's not intended to pass block headers to passing block headers for others like the telepathy-like client. It is kind of a more native feature of it for it to be passing over block headers. So it would be a very different flow. But this is kind of the whole point for standardizing this interface, is from Hashi's point of view and from the kind of the end user's point of view, the interface that they interact with is standardized. We'll jump into Giribashi. So this is our kind of ownable version of this. This is restructured a little bit to what you'll see in the main branch of the repo. You can jump in and play with this quarantine branch if you want. I think this is probably what will end up in main relatively shortly. But essentially what it's doing here is wrapping each of the kind of setter functions, or I guess I'll jump into the base contract here for it. We have a handful of kind of state variables here in terms of the Hashi contract that we're interacting with, a mapping to the various adapters for each chain ID, for each domain, and a mapping of the different domains and kind of their thresholds and current count of adapters in those domains. The important thing to kind of note here is basically each of these calls to kind of the setter functions and the functions to kind of enable and disable Oracle adapters is ownable. Essentially just has this only owner modifier, which means that the owner of this account is the only account that's able to call these functions. So it's kind of really basic governance that that defers any additional complexity to something outside of this mechanism. The newer version of it that we're playing with at the moment, this quarantinable Hashi, is a kind of similar concept, leverages the same base contract, but adds some additional mechanisms around when you can enable or disable an Oracle adapter. So in this case, an Oracle has to essentially misbehave before it can be removed. So misbehaving would be either taking too long to report a given hash when it's been requested, or reporting a hash that's different from a threshold of other oracles. So if at any time, someone can kind of challenge an Oracle adapter to report a hash, and if it's unable to do so within whatever is kind of defined as its timeout range, then it can be essentially put into a quarantine state where governance can replace it. And then similarly, if someone challenges it and it reports a value that is different to what a threshold of other adapters have reported, then similarly, it'll be put into this quarantine state, and then anyone can, governance can come along and replace it. Yeah, I guess the last thing that's probably worthwhile us looking through here is the message passing side of things here. So this is Yahoo contract, and then Yahoo contract is the corresponding one on the other side, a kind of message executor. So Yahoo is our message dispatcher. You essentially have this entry point here, relay messages to adapters, which is going to take your messages and kind of put them into storage and emit an event from them. From there, you can dispatch those messages to adapters that require kind of an active push. So this would be things like the Gnosis Chain AMB would require you to actively call that required to pass message function for it to pass a message over the bridge. Other mechanisms may not require you to actively do anything more than just have put it into storage, kind of if they're dependent on storage proofs, for example. And then there's a kind of convenience function here to not just dispatch them, but also to relay them. So dispatch messages to adapters means you're both putting basically just calls each of the above two functions in kind of one convenient call. And then once you've created a message, Yahoo contract on the other side is the thing that would ultimately execute the message on your destination chain. So here you have this execute messages entry point where you're going to drop in the message IDs, which are just a counter on the Yahoo side, along with the messages, the addresses that sent them, and then the various Oracle adapters that you should query. One thing that's maybe not immediately obvious here is that if you want this to be ownable, essentially if you want to make sure that only a specific set of oracles can be queried, then you would plug your instance of the Yahoo contract into your Giri as opposed to into Hashi directly. They expose the same interface here in get hash. So yeah, you can plug into either of them. The quarantinable Hashi also exposes the same get hash interface there, or it's get hash entry point. So you can, kind of plug it into any or all of them. Again, kind of following this relatively modular design pattern. And yeah, want to essentially what this is going to do is just validate that the messages and senders, message IDs that you passed in correspond to the hashes that your various Oracle adapters report. And if they all match up, then it will execute the message and return whatever return data your messages returned. I guess the last piece of that then is this Zodiac Hashi module, which essentially just allows you to control an avatar like a Gnosis safe via calls from Yahoo. So kind of end to end, you can have an account on one chain, send messages over Yahoo to be executed by Yahoo, and then have that Yahoo contract interact with this module to ultimately trigger a safe to do things. So you can have a safe on your destination chain be the thing that controls your DAO's treasury, for example, on that destination chain, or controls your DAO's deployment of your DeFi protocol or whatever it is on that destination chain. I think that's a pretty good overview of where Hashi is at right now. I guess
yeah. Awesome. Okay, so we have got a few questions, some that have just come in while you were doing this demo. So I'll ask those ones first. Evgenio asks, oh, I've lost it in the chat.
I can see a couple of questions here. I see JC asks, what's the best way to get involved with Hashi development? I'd say jump into either the Gnosis Guild Discord or the Gnosis Chain Discord and just shout at us. We'll happily kind of get you involved. Otherwise, create issues, create PRs on the repo. We're really excited to have people contribute. So wherever you reach out to us, we'll enthusiastically reply.
Awesome.
Then JC also asked, how much can you customize the threshold before quarantine? So the way that it's defined at the moment, and this is kind of more so even than the rest of the repo, very much still in active development. Let me jump back to this quarantinable version of this. So the way that it's set up at the moment is you can kind of initialize a given domain, so a given chain ID. Let's see where I put that. So yeah, you have this kind of init settings function here where provided that the settings have not already been set, and that let's have a modifier for this somewhere, but we won't. It might not actually be. Let's have a look. Here we go. Okay, here we go. So this is not what I'm thinking about. So there's two different things. So initializing the settings for each given adapter happens kind of during the process where you actually enable or replace the adapters, and then setting up the thresholds for each domain is going to happen here in our set threshold function. We've got this internal function here that is only going to let us do it if right. Sorry. So it's basically just going to do this check to make sure that the threshold is currently set to 0 and the domain count is currently set to the count, the total number of adapters enabled is set to 0. So basically, if it has not yet been initialized, then it will let you set the threshold. As soon as you add an adapter, then it will no longer let you set the threshold. So in order to change the threshold, you have to either be initializing or have reached this kind of no confidence state where all of the Oracle adapters can be removed by governance. And then the last question here from JC was, can we quickly go over the dispatch again? What does it do? I kind of rushed through that a little bit. So we have this dispatch messages function here. And basically what it's going to do is you pass in an array of messages, and it's going to take that array of messages and just put them into storage. So you have this or I should say, put the hash of those messages into storage. So we have this mapping here, hashes, and it's going to key them just via a counter. So the ID for a given message is just going to be whatever the current count is. And yeah, it's going to take your message and calculate a kind of unique hash from that message that we can then replicate on the destination chain by providing these kind of same inputs. Some of these are variables that are in state in your instance of Yahoo. So things like the address of this Yahoo contract and the chain ID would be things that you store in state over here in Yahoo. So you've got this, in Yahoo. So you've got your Yahoo and chain ID are your two kind of state variables there. And then sender is sender is sender is eluding me right now. I'll come back to that in a second. But regardless, what we're doing is grabbing a hash, putting it into storage, and then just emitting it as an event and incrementing a count. The idea here is that then whichever other kind of route your underlying mechanisms take to produce the message on the corresponding destination chain, there should be a way for them to kind of access this hash. It's in storage, so your bridge mechanism or one of your bridge mechanisms is relying on storage proofs, then it has storage to access. From that storage, we can also then do this kind of dispatch messages here where we're triggering a hash that's in storage to be sent via mechanisms that require kind of an active push. So the A and B is a good example of that, where you have to call this required to pass message function. So we can pass in an array of messages. Sorry, there's relay messages, not dispatch. Relay messages here. We can pass in an array of message IDs and trigger those message IDs to be kind of pushed through this array of adapters and pushed to an array of destination adapters. Yeah, I think that explains it reasonably well.
Yeah, I think so. Yeah, Josie's just said explain nicely. There are a couple of questions in the questions tab as well. Yevgenio says, it looks quite complicated. How much time did it take to write down a code for the first adapter?
Oh, yeah. I don't know. The first adapter was this A and B module one. I have done a fair bit of work with A and B in the past, so was reasonably familiar with it. I think, how long it takes you to write an adapter really depends on how familiar you are with the underlying mechanism that you're plugging into. The nice thing with kind of adapters is really you're just kind of translating between one system and another. So if you can understand the interface for the system that you're interacting with, so say you're working with this kind of ZK-like client system, then all that your contract code really needs to do is understand kind of what the interface for that ZK-like client is, kind of where it could make a query to that light client contract to get the hash for a given block, or to get some information from which you can derive or extract or whatever the hash for a given block. So you don't have to be kind of intimately familiar with the underlying mechanism for a given oracle. You really just need to understand kind of the interface. Like if you give it this bit of information, what is it going to return to you, and then how do you derive the information that you want ultimately the hash for a given block, for example. How do you derive that from the information that this system is going to return to you? And yeah, if you can kind of get to that depth of understanding with an underlying oracle mechanism, then you should be able to fairly easily write an adapter for this to kind of plug that mechanism into Hashi.
Awesome. Okay, we have one last question from JC. Yeah, why should we use it if it's not audited?
You absolutely should not use it because it hasn't been audited and it's still very much a kind of early stage. I think you should build with it though, because it will be audited. And actually, I say it hasn't been audited. It has actually had one audit completed already, but it's not audited to a point that we're happy with yet, and it's not kind of stable to a point that we're happy with yet. It's certainly not production ready, but it's certainly is hackathon ready, and certainly is kind of ready to have kind of people building towards production readiness. It will be, I think, at a state that we're happy with calling it production ready. I'd say within a month or two. And so, yeah, if that timeline aligns well with when you would like systems that you're trying to build to go live, then I'd say Hashi is a really great choice. And I think the answer to kind of just why build on Hashi in general is that when it is production ready, it will almost certainly offer better security guarantees than trusting any individual bridge mechanism.
Cool, awesome. I think that's all the questions now, and kind of perfect timing as well. We're kind of between that 45 minutes to an hour mark. Yeah, just to build on that last question as well, it's like you were saying earlier, Auryn, right? It's an early stage for Hashi, and it's the best time to make a difference if you want to by building on it. And so that is also a big incentive to get on Hashi, so you can make your own changes that you see fit for your own use case, right?
Absolutely, yeah. I mean, this is, again, it's rare that you get an opportunity to jump in and really be influential on a project at this early of a stage. So yeah, by all means, exert that influence. If you have opinions on how things should be implemented, how we could improve things, if you find bugs, if you find issues, if you can save gas, then yeah, jump in and have at it. We would love as much feedback as possible.
Yeah, awesome. So yeah, you heard it here first, guys. Get on it. Make your own changes. Awesome. Thank you so much, Auryn, for speaking today. That was really awesome, and really exciting to be able to kind of see Hashi at an early stage. Just wanted to drop your Twitter in the chat. So if anyone wants to kind of get in touch or keep updated, I've just put the link in, and then everyone else check out Gnosis Guild. I think you're the lead. You lead Gnosis Guild.
Yeah, I guess I don't know. We have very fluid and esoteric titles for us, but yeah, founder and tech lead kind of sums it up.
Awesome. Yeah. Well, yeah, if you guys want to go check that out, that would be awesome. And of course, Gnosis Builders as well. Cool. Thank you so much, everyone, again for coming and stopping by today. Yeah, it's really great to see you all here and engaged. And a few little housekeeping things. Our next workshop will be May 15th. So we've got a little while until then. So for the time being, please stay in touch with me. I do want to also just share my Calendly link. So guys, book a call with me as we're getting further and further into this hackathon. And kind of, I'd love to stay in contact and stay up to date with how you guys are doing in your projects. Of course, we are offering this one-to-one, almost like a mentorship opportunity, so I can see how you guys are getting on. Yeah, so book a call there. That would be really, really awesome. Auryn, have you disappeared? I was going to ask, would you like to share any final words before I end this event? And if you're not available, that's absolutely okay as well. Cool. Well, I hope to see you guys very soon. Please stay in contact in the chat and via email, via Discord. Auryn, any last words?
I'm still here. I just realized I'm still screen sharing as well. I can kill that.
No problem.
Yeah, no real last words. Just thanks very much for having me. This was a lot of fun. Really appreciate all of the questions and everyone for just tuning in and paying attention. Cannot wait to see what folks come up with.
Awesome. Yeah, so am I. I'm super excited. Okay, everyone, we'll wrap it up there, but see you guys soon. See you guys. Bye.